To add here the change of base formula. So here's one. Log in any base. So I'm going to put b, any base, of a product, x times y. But it can be anything. Any expression times another expression. Is nothing else but the sum of these two logs. Log base b of x plus log base b of y. So notice that this is not log of x times log of y. No, there is no rule for that. It's log applied to an expression that is a product. If the expression is a product, you can simplify this into the sum of the two logs, log of x and log of y. This is not a distributive law, nothing of that kind. So anytime you apply log to an expression that is a product of two quantities, you can write this. And also backwards. So if I have a sum of two logs and they have the same base, and it's a sum, this expression is nothing else but log base b of the product of the two expressions. So it goes back and forth. The second property, of course, this is the product property, product rule. There is a rule for a ratio. Again, the same idea. If I apply log to a ratio, I can separate it as a difference of logs. The top minus the bottom. So now if I want to go backwards, all I have to remember is if the log has a negative symbol in front, -1 in front, its expression must come from the denominator. If it has positive in front, its expression must come from the numerator. Okay? Last one. Log base b applied to x raised to a power. I'm going to call the power a. So this was a ratio rule or law. Now this is the power rule. The power becomes a factor and it goes in front. So this is a multiplied. Factor means multiplied. Log base b of x. And of course, I'll go backwards. If I see a number in front of a log that multiplies, that number multiplies log, I know it really comes from the power of x. These are the laws. There is one other thing that I would like to add here, which is, I wouldn't say it's a law, but it's called a change of base formula. For example, if I want to determine log base 3 of 7, this really is asking us to find what? The power I raise to get. Right. I will never be able to tell you what that is by hand. But we can determine it with a graphing calculator. And here it is. Any of these two, you don't have to calculate both. Common log, the calculator has only two. The newer calculators, however, allow you to put in the log with the base you want. The older calculators don't have that option. So in this calculator, I only have log, which is base 10, common log, and I have ln, which is natural log, which is base e. So I'm going to use either one, and I'll show you, you can write both, but as long as the numerator and the denominator have the same log. So log at the top is from 7, and log in the denominator is from 3. In the past, some students confused this with this. You notice this is totally different. This is log applied to a product, which changes into a difference of logs. And this is log base 3 of 7, which is a ratio of two numbers represented by logs. So if I want to use natural log, I can in the same way. Because the answer will be only one number. So when I go to the calculator and I punch in natural log 7 divided by natural log 3 and close, I get 1.7712 approximately. And if I want to check, how will I check?
The square root of the second of the answer.
So 3
To the square root.
3 to caret the previous, exactly, previous answer. And when I hit enter, what should I get?
So,
Exactly. Now, if you truncate and you put just 1.77, for example, you will not get 7. You will get something very close to 7, but not 7, because you did not include all the decimal. Okay, I would like to practice these rules now. On page 329, we have two types of problems here. One, to condense, and the other one to expand. On a simple example, from here, from this to this, I expand. From 1 log into 2 logs, I expand. From 2 logs back to 1 log, I condense. Okay? So from here to this, it's an expansion. From here back here, it's a condension. Well, I mean, I condense. So let's choose anything you would like from 19 through 44, first set on page 329.
16.
Very good. From 19 through 44. Okay, let's start with 16. Let's see what 16 is all about. Good. 16 is evaluating. That's fine. That's fine. Log base 2 of 8 raised to the 33rd power. Excellent. There is one rule that I can apply here. Logs have 3 possible rules. Log applied to a product, ratio, or power. Which of these 3 is applicable here? Number 1, number 2, or number 3?
Power.
Right. So I will put 33 in front as a factor. So 33 multiplies log base 2 of 8. I would like to simplify log base 2 of 8 if I can. So I'm asking myself which number I raise to get 8. So then what number will this be? 3. So 33 times 3 will be 99. It's a very good pick. Now let's pick from 19 through 44. Okay, I will pick 30. Log base A of x squared over y z to the 3rd. There are 3 rules. Once I have a ratio, I will have to start with the ratio rule or the quotient rule. What does that mean? How do I change this? How do I expand it?
Log A
Of
x squared
minus.
log A of yz.
Very good. There is one rule or property that I can apply to the first log, and I'm done with it. There is nothing else I can do. What property will I apply here? Right, so the power comes in front as a factor, 2 multiplied by log base A of x. Now careful, minus, put parentheses, and tell me what property should I apply to log base A of y times z to the 3rd? Exactly, so how do I write it?
Log A y plus log, or would it be log A y cubed?
Z cubed. Very good. Now I will distribute the negative sign.
For just, does it matter which you put the cube to, or does it have to be since it's yz cubed?
If it's not in parentheses, this means that y has power 1.
Oh.
I can't change that. If it were in parentheses, then yes, I would have done something else. Yes, but it says y times z cubed. Perfect. So now I distribute 2 log base a of x minus log base a of y, and I have one more property to apply to the last one. Minus, that's it, 3 log base a of z. Perfect. Feel free to choose another, and then I'd like to go back, continue with condensing, going backwards. 36 it is. And in 36 we have log base 5 of the square root of x minus 1 over x plus 1. Since there is a power involved in there, what power? What power? Exactly. Very good. So this is x minus 1 over x plus 1 raised to 1/2. I have to clear the power first in order to expand. So where does 1/2 go? Good. So now 1/2 stays outside. And what do I have in parentheses?
Log 5 x minus 1 minus log 5 x plus 2.
It was x plus 2?
Or, wait,
Oh, it's, okay, no, sometimes I copy. Okay, so final step, just distribute 1/2. So 1/2 log base 5 of x minus 1 minus 1/2 log base 5 of x plus 1. And this is it. Now I would like to condense 45 through 54. I'll choose 48 and then you choose the next. Log base 5 of x squared minus 1 minus log base 5 of x minus 1. How will I condense this?
Log base 5 x squared minus 1 over.
Very good. And I can factor the top and try to simplify. How do I factor the top? I'll simplify by x minus 1. And the final simplified form, log base 5 of x plus 1. Good. Choose anything else you would like. Any other condensing. Condensing is extremely useful for the next chapter. Not chapter, section. $52. Very good. Simon, you said something? Oh, I thought you chose something and maybe I didn't hear. 52. 2 parentheses log base 5 of x plus 2 log base 5 of y. They really like base 5. Log base 5 of z. Good. Perfect pick. When there is a number in front, I cannot condense before I apply the power rule. Forget about this number for a moment. I'm talking about this number and this number. So 2 log base 5 of x stays as is, but this one has to change, and this one has to change.
Log 5y squared.
Exactly.
Log 5z cubed.
Very good. Still leave the 2 outside. And now you know that if the log has plus in front, its quantity goes to the top. If it has minus in front, its quantity comes from the denominator. So 2 log base 5 of
5 y squared.
X times y squared over, yes, x y squared over z cubed. If there is plus in front of a log, its quantity comes from the top. Plus y squared comes from the top. Minus z cubed comes from the bottom. Now, if I want to go backwards and recover from here, recover this, I will write log base 5 of x plus log base 5 of y squared minus log base 5 of z
So if it
cubed.
was negative log 5x,
Yeah.
it would be xz on the bottom.
You mean negative here?
Yeah.
Yes, it would have been y squared xz to the third. Yes. Now, what do I do with this 2? What does a number in front of a log? It's the power. It's the power this time of the whole thing. So this is x y squared z to the third. And I can further simplify. So log base 5 of x. Very good. Very good. Do we need more condensing and expanding? Yes? Yes? Or are we okay? We need more? Okay, which one? Very good. Which one?
Number 53.
53. We have 1/3 log x plus 2 to the third plus 1/2 brackets log x to the fourth minus log of x squared minus x minus 6 squared, everything closed. So 1/3 common log, which is base 10, common log of x plus 2 to the third, plus 1/2 log x to the fourth minus log x squared minus x minus 6. Perfect example. Good. What can I do to the top, to the, not top, to the first one? Forget about the rest for a moment. Just this one. What can I do? Yes, this becomes the power of all this, which will be the cube root. And how much is the cube root of something cubed? Exactly. So this is log of x plus 2. And I simplify the first log fully for now. Plus, leave the 1/2 in front for a moment. Now tell me what you would write in the middle, in brackets, I should say. Log of, very good. Good. Now I have to eliminate this 1/2. What does that mean? Yes. So when I apply the square root of on this, what will I get? X squared over. Very good. Final step. Now I have a log plus another log. Where does this come from? Good. And I will have to factor x squared minus x minus 6 in the hope that I can simplify this x plus 2. I'm hoping. So log x squared x plus 2 divided by. I reverse them because I don't want to put x squared at the end. So I prefer x squared times x plus 2. It's the same thing. How will I factor x squared minus x minus 6? Excellent. Indeed, x minus 3 and x plus 2. And therefore, I'm allowed to do this. So finally, it's x squared over x minus 3. Very good. Good pick. Any questions? Four point five has two parts: exponential equations and logarithmic equations. There are many different types of exponential equations. Here is the easiest possible. We start from the simplest. Let's say 2 to the x equals 2 to the third. Is this an exponential equation? Yes, because the variable is the exponent. Okay. So now I'm telling you this because I don't want you to think that I'm simplifying the base or I'm erasing the base or I'm doing anything. No. I want you to pay attention for a moment. Two numbers are equal and they have the same base. What has to happen to their exponents? One more time. Two numbers are equal and they have the same base. What has to happen to their exponents? Exactly. So this is how we think about this. And I'm done. It's the simplest possible exponential equation. Now the next one will be slightly more difficult. So let's say 1/4 2x minus 2 equals 8 to 2x plus 1. Can I use the same concept from before? No, I can say the two numbers are equal, but I cannot say that they have the same base. Now I'm going to ask myself, can I write 1/4 and 8 with the same base? Because if I ask you, and we'll get to that in a minute, 3 to the x equals 7 to x plus 1, you will have to say that 3 and 7 can never be presented with the same base. So this idea will never work here because 3 and 7 are not the same base. But my question here is, can I present 1/4 and can I present 8 with the same base? And the answer is yes. How will I present this? Always think in prime factors. So what can I replace 1/4 by? 2 to -2, indeed. What can I replace 8 by? To the? Very good. So I replaced 1/4 by 2 to -2. I replaced 8 by 2 to the third. But now I have one property that I have to apply. 2 raised to which power? What do I do with the exponents? As well as here. What operation do I apply? What do I do with -2 and x minus 2? Yes, I have to multiply them. Very good. -2x plus 4 equals 2 to which power? Now I'm happy because I finally, after all these algebraic manipulations, I can come back and use the same concept. Two numbers are equal and they have the same base. What has to happen to their exponents? Two numbers are equal, they have the same base. What has to happen to their exponents? Yes. So from here I know that -2x plus 4 must equal 6x plus 3. There is no other way. I move 6x, I get -8x. I move 4, I get -1, so x equals 1/8. Can it get worse? Yes. It can. Like this one. That will be my next level. So any questions on this problem? So this was the first, this was the second. Any questions? So now this will be the third, in which I cannot present left and right with the same base. So let's work on that problem. 3 to the x equals 7 to x minus 1. What do I do in this case, in which left and right cannot be presented with the same base? I have to come back to a previous problem or problems that we worked on. So for example, when we solved the square root of x minus 1 equals 4, what did you tell me to do here? How do I solve the square root of x minus 1 equals 4? What do we do? Yes, but why do I square and not cube, for example? Exactly, because this operation has this as its inverse. That's why we chose 2. Power 2 and power 1/2 are inverse operations. That's why they cancel each other, their effect on x minus 1 in this case. What will be the mechanism that I need here? What should I do to both sides? Because like I did here, square, I have to square both sides. What should I do to both sides so that I can bring these powers down? And there is only one function that has that property, that if I apply it to both sides, it will allow me to put the power in front as a factor. So what will I do to both sides? Here I squared. Here I have to use the inverse function of what I see here. What will be the inverse function of an exponential? This is an exponential function. What is the inverse function of an exponential? It's called?
Actually, the paradox. No.
Yeah, it's also a power, but it's log. It's the log function. So I'm going to apply natural log to the left and natural log to the right. It has to be the same base. I chose natural log. You can say, I don't want natural log, I want common log. That's fine. The answer will be the same. This is the only function that allows me to bring the power down, right? The log function. So what will you write on the left? I bring x in front, right? I'm applying natural log to both sides. Remember when we had, for example, sine x equals 0.3. What did we do to both sides to find x? Yes, so we applied here sine inverse and we applied here sine inverse. I'm doing the same thing here. So these two are equal. Their logs have to be the same. So now x natural log 3 will equal x minus 1 natural log 7. If you omit parentheses on x minus 1 in front of natural log 7, you will change the problem. So please keep the parentheses in there. So then x natural log 3 equals x natural log 7 minus natural log 7. So natural log 3 and natural log 7, I know they look fantastic, but they're just numbers. They look sophisticated and so on and so forth. But they're just numbers. Now I have x on both sides. What should I do next? Again, I'm solving for x. Any suggestions?
Possible to subtract x minus.
I have to. So x natural log 3 minus x natural log 7 equals negative natural log 7. Perfect. Now I would like to combine them, but they are not like terms. But there must be a way for us to continue. What should I do? I have to factor out x. Natural log 3 minus natural log 7 equals negative natural log 7. And now the final answer is? Let's see, in case we need to put this in the graphing calculator, you have to be very careful. parentheses, 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 parentheses. So in parentheses, negative in front, natural log 7, and close the parenthesis and close the parenthesis again. Divide by left parenthesis, natural log 3, close the parenthesis, minus natural log 7, close the parenthesis and close the parenthesis. And then press enter. I claim that the answer is 2.2966. I want to check my answer. Remember what the function, what the equation was? 3 to the x. On the other side, 7 to x minus 1. What I recommend when you want to check, it's easier if you move 7 to the other side and you are checking in this equation. It's the same thing, but you will be able to, if you check in this equation, then you will be able to use the second key and answer. So 3 raised to the previous, in parentheses, I always put parentheses, to the previous answer, minus 7 raised to, in parentheses, the previous answer minus 1. So if you do this, so 3 raised to the previous answer minus 7 raised to the previous answer minus 1. Then you can use, without making a mistake, if you want to separate them into two different functions and not do this, then you will have to be very careful when you put in the previous answer, because when you calculate this one, it will give you something, but then it will give you an answer that will come into here. And you don't want to do that because you're going to get something false.
Yeah, that's how I did it in mine, and I got one digit off all the way to the right.
Right. Right. So when I press enter, what should I get now?
2.2966.
Careful. This is what I plugged in.
Oh, that's right.
Exactly. I have to get exactly 0. If I don't get 0, something is wrong. So it's always better, because then when you calculate this with the previous answer, then when you calculate the second one, you will use the previous answer from here instead of using this. So if you put it in one row, then you recall the same number both cases. I'm not sure, is it clear what I'm saying or not clear?
Yeah, it is.
Okay, so always try to check on something like this.
I just lost you right. You got your final answer going from the last step to the final answer. Right?
So this is a number, and this is another number. So I'm solving for x. I have to divide this by this.
Oh, okay, I got you.
This by this.
Gotcha.
Because this is the number that multiplies x, and that's what I have to divide both sides by. Better?
Yep.
Okay. So, and yes, let's look at 26. We're not done here, in the sense that there are other types of exponential equations. So let's look at 26 on page 338. 10 divided by 1 plus e to negative x equals 2. And then there is one more type. Okay, let's look at this and decide what to do. If I'm given something like this, what should I consider first? What should I think of? Okay, here's my hint for you.
Cross multiply.
Absolutely, it's a proportion. I have to cross multiply. What do I write after that? Yes, equals. And let's put parentheses for now. Good. Now, I have two options. One is to distribute the 2. The other one to get rid of 2, and I prefer to get rid of 2. How will I get rid of 2? Yes, divide both sides. So I have 5 equals 1 plus e to negative x. So I'm trying to clean it up. I'm trying to have a simple exponential expression on the left or on the right. Now I have one more step to clean it up. Yes, so I have 4 equals e to negative x. I am back to this situation where the left and the right cannot be presented with the same base. 4 and e will never be presented with the same base. And I do have a mechanism for this, as I had for this, or as I had for this, to use the inverse function of the exponential function. Yes, I will apply natural log to both sides. The left-hand side is natural log 4. And what is the right-hand side? Negative x, very good. I should write multiplied by natural log e, but I know what natural log e equals to. Let's think. What is the base of natural log? Careful. The log is base 10. But natural log has base? Exactly. Look at the graphing calculator. You have the same key. E to the x and ln are the same key. 10 to the x and log are the same key. Exactly. E raised to which power is e? Exactly. That's why this is 1. So I have negative x equals natural log 4, but I want x. In that case, I have to do what? Multiply or divide by negative 1. If you want to approximate it, you have to put it in the calculator. I will never be able to tell you what this is. Negative natural log 4. And that's negative 1.386 approximately. Okay. Good. I would like you to choose from 29 through 36. Now we are getting sophisticated. Now these are combinations. Even this one was a combination, was an exponential expression combined with a rational expression and so on and so forth. So now this is sophisticated. 29 through 36.
34.
Okay, let's start with 34. I don't want you to get scared. There's nothing to be scared of. Yes, it looks awful. There's x squared, 10 to the x, 10 to the x, 2, 10 to the x. What do you think we should do? You should always have at least 1 or 2 ideas, even if they're wrong. Careful. I cannot apply log to a difference. So if I don't write this. If I apply log here and I apply log here, this is fine because it's a product. But I cannot apply to a difference. Remember, we only have 3 rules. Log applied to a product, to a ratio, and to a power. There is no log applied to a sum or a difference. So I'll get stuck. I will not be able to continue. Okay? So that will not work. So, other suggestions? 10 to the x. I first move 2 times 10 to the x to the other side. And I notice that these 3 terms have something in common, correct? Which is 10 to the x. And now what is left in parentheses? How do I factor x squared minus x minus 2? Very good. X minus 2 and x plus 1. It appears that we have 3 factors. I mean, I shouldn't say that. They are 3 factors. So one factor is 10 to the x could be 0. In a minute, we'll talk about that. What is the other possibility, and what is the third possibility? Very good. Now, let's discuss the first possibility. If we graph 10 to the x, what type of function is it? It's exponential, but is it base greater than 1 or less than 1? Because if it's greater than 1, it should look like this. If it's less than 1, it should look like this. Greater. So it's this graph. So this is 10 to the x. So 10 to the x is this graph, and 0 is this graph. Is this ever possible? Is there a power of 10 that will make 10 to that power be 0? Will these functions ever meet? This function and this function? No. So there are no options here. Never. 10 to the x can never be 0. It's always greater than 0. Very good. So the equation has 2 solutions. I like to choose one more, like 30. E to 2x minus e to x minus 6 equals 0. And no, if you try to move 6 to the other side and apply log, it will not work because log of a difference does not exist. I mean, you cannot simplify it. So what do I do now? We worked on some of a long time ago, problems like this, where we said, oh, I wish I could factor this, but if I let t be da-da-da, then I can change this equation to something very simple that I can solve. Like a change of variable or substitution. So I will let t be to the x. So I will let this be t. But only if this turns out to be, otherwise it's not going to work. So if I denote this by t, and if this one is not exactly, then it's not going to work. What should this be? Exactly. And it is. Let's square both sides here. If we square this, I get t squared. If I square e to the x squared, I copy the base. What do I do with the exponents? Yes. So this equation, although it's exponential, it is also quadratic in form. So then this is t squared minus t minus 6 equals 0. And this, I know how to factor. You can say to me, and I will agree, I don't need all this. I can factor this by simply looking at it. I'm fine. You don't have to use a change of variable or a substitution if you don't want to, or if you don't feel like it, or you don't need it. So now, how do I factor t squared minus t minus 6? Excellent. So then I have 2 options for t, -2 and 3. But this is not good enough. It's good, but it's not good enough. Because now I do have 2 more equations to solve. What equations? Yes, e to the x equals -2 and e to the x equals 3. Now let's graph e to the x. Is it an exponential function? Base greater than 1 or less than 1? E is 2.71. Increasing, right? At 1. So this is e to the x. So here is -2. So the left-hand side I graphed it as e to the x. And -2 is this. In how many points do these 2 intersect?
0.
Never. Right. Perfect. But now here is 3. So the second equation will have solutions. But since I cannot present E and 3 with the same base, I have to use the mechanism that good. So this is x equals natural log 3. So this intersection right here is at natural log 3. Let's find natural log 3. Natural log 3 is approximately 1.0986. So approximately, or I should say x approximately 1.0986. These are the major types of exponential equations. Now let's look at log equations. Okay, I'm going to start with 42. Same page, 338. Log base 3 of 2 minus x equals 3. Coming back to an example that I used a few minutes ago, this one. So when I solve, I square both sides and I get x minus 1 equals 16. And then I finally get x equals 17, correct? What should I do next? So I square both sides, I get this, and then x equals 17. It's part of the problem. What do I have to do before I say 17 is indeed the solution? I must go back and check in the original problem, because this power may produce solutions that do not work in the original problem. That's part of the solution. So when I plug in 17, 17 minus 1 is 16, the square of 16 is 4. The same thing here. This function, if you remember I said, is not a friendly function. So you have to use one of the following two methods. So number one, state domain. I'll show you in a moment. And number two, check solutions. It's up to you which method you want to use. And you don't have to be consistent. In some equations, you will state the domain. In other equations, you will check solutions. I don't mind. But you must choose to use one or the other on each and every log equation. So I'm looking at this, and I generally prefer this because I forget sometimes to go back and check. Or I may forget. So the domain of this function, what do I have to write and solve to find the domain? I know that log is a function that has to be applied only to what? Only to positive numbers. So this must be a positive number. So 2 minus x positive, negative x greater than negative 2, x less than 2. If the solution is not a number less than 2, it will have to be disregarded. So that's the idea of the state domain. If you say, I don't want a state domain because I will always remember to check solutions, that's fine. You will find the solution and you will go back and check. I prefer this method. You choose what you want. So now the equation is log base 3 of 2 minus x equals 3. And I know how to change this equation into an exponential equation. How do I change it? Base
3 to the third equals 2 minus x.
Excellent. 27 equals 2 minus x. Subtract 2. 25 equals negative x. X equals negative 25. Is this in the domain that I found on the raw equation? Is negative 25 a number less than 2? Yes. So this is the solution. Okay. Problem 48. Log base 5 of x plus log base 5 of x plus 1 equals log base 5 of 20. Okay, I prefer stating domain. You can say no, I will check. So what will be the domain of this function? One of the reasons why I'm using a domain is because I want to practice domain with you, so you don't forget. So log base 5 of x, what will be the domain of this? X must be perfect. What will be the domain of this? X plus 1 greater than 0. So this one is x greater than 0. This one is x greater than negative 1. I have to find the common domain, as we know from a long time ago, chapter 2. So one domain is 0 to infinity. The other one is negative 1 to infinity. Can anyone give us the common domain? Very good. So if the solution is not a positive number, it cannot be accepted. Good. Now I need to condense the left-hand side. How do I condense the left-hand side? Using properties of logs.
Log base 5 x times x plus 1.
Very good. Allow me to write it as x squared plus x. Exactly what you said. X times x plus 1 is x squared plus x. Now, please pay attention for a moment to the mechanism, where I'm not deleting anything, I'm not dividing by log, I'm not simplifying by log, nothing. So I have two numbers that are equal. These two numbers are equal. And they have the same base.
X squared plus x plus 1.
Exactly. There is no other way. That x squared plus x must equal 20, because log base 5 of 15 does not equal log base 5 of 20. So they must be the same, like the same concept with the exponential function. And now I know that this is a quadratic function. What do I do to solve it? What should I do? Very good. And I'm hoping that this is not a big deal and I don't have to use a quadratic formula and it's possible to factor easy. So I have two options, negative 5 and 4. Not so fast, because I stated my domain from the beginning. What do I conclude?
X is greater than 0, so the answer is 4.
Right. And I don't have to go back and check. Now please choose any log equation you want, from 37 through 54. I consider the exponential equation slightly more difficult than log, but log are a little bit more difficult because you have to think about the domain or go back and check. With the exponential ones, you don't have to, but with the log, it's a must.
Number 53.
53. Log base 9 of x minus 5 plus log base 9 of x plus 3 equals 1. Again, if you like to use my method, that's not my method, it's the method I like to use. You will write x minus 5 positive. You will write x plus 3 positive on the raw equation, not after you condense. The domain has to be stated on the raw equation. And then this one means greater than 5, and this one means greater than negative 3. What will be the common domain then? One of them is greater than 5, the other one greater than negative 3.
X is greater than 5.
Yes. If the solution we get is not a number strictly greater than 5, not 5, but strictly greater than 5, then we have to disregard it. Okay, perfect. Now I have to think of condensing the left-hand side. How do I condense? Log base 9 of
X minus 5 times x plus 3.
equals 1. And now how do I change this into an exponential equation? And then yes, I will distribute x minus 5 and use FOIL on x minus 5, x plus 3 in a minute. But how do I change this into an exponential equation now?
9 to 1 power.
Exactly. So x squared plus 3x minus 5x is negative 2x as minus 15. So I distributed x squared, positive 3x, negative 5x, and then minus 15. So now the equation is x squared minus 2x minus what? 24 equals 0. Again, I'm hoping that there is not too much to this. Very good. X equals 6 and x equals negative 4. Again, not too fast, not so fast. What?
That's greater than 5.
So the only option is x equals 6. And I just want to choose a word problem from here. Look at how many applications this function has. It's amazing. Fish population, a logistic growth model that has exponential in it. Even the transparency of a lake has an exponential function in it. The atmospheric pressure has a log function in it. Cooling of an engine has a log function in it. Again, electric circuits and batteries, and amazing. It's an amazing function. I should say functions. So I don't know. Let's look at 86, cooling an engine. And then I'll stop. Suppose you are driving your car on a cold winter day, 20 degrees Fahrenheit outside, and the engine overheats at about 220 degrees Fahrenheit. When you park, the engine begins to cool down. The temperature T of the engine, T minutes after you park, satisfies the equation. Natural log T minus 20 over 200 equals negative 0.11 lowercase t. Solve the equation for T. This is really, I would say, requires a little bit of mathematical sophistication to solve this. Okay? I'm not going to hold you over. I know I only have 6 minutes. So if I don't finish in 6 minutes, I'll stop. So I have this equation. It has two variables. It has uppercase t and it has lowercase t. And I'm asked to solve for the uppercase t. So one more time. I have natural log t minus 20 over 200 equals negative 0.11 t. This is a log equation. If it's a log equation, it can be converted into an exponential one. What is it? What exponential equation will replace this log equation?
to
What is the base here?
base, that's 10.
LOG. LOG has 10.
So, yeah,
E. E raised to
negative 0.12
equals,
t minus 20.
good. I'm much closer now than I was before. Now what is this and what do I do with it? Okay, okay. 200 e to negative 0.11 t equals t minus 20. And I've got t, which is
280 negative 0.01 t equals 20.
perfect. Let's see what they want in part B. Use part A to find the temperature of the engine after 20 minutes. T equals 20 minutes. So that's part B. So I have 200 times e to negative 0.11 multiplied by 20 plus 20. Here it is. 200 multiplied by e raised to parentheses negative 0.11. I could have multiplied those two. Multiplied by 20 and outside plus 20. So the temperature 20 minutes later will be approximately 42 Fahrenheit. So T approximately 42. This almost completes the chapter. I have to show you more word problems. And that will be the end of chapter 4. And then we'll continue with chapter 11.